Hi, my name's Ethan Pearson,
I'm Joseph Duncan.
And I'm Riley O'Shea.
and this is our final FED presentation. On our FED day, we prepared the fountain for transportation and we brought it to the McKimmon Center. When we arrived there wasn't a place for the fountains. In the morning session, the fountains were actually supposed to go in the afternoon, but there were a few other teams there and we got it together on a table. And we made some last minute adjustments to the water wheel to counter some problems with splashing that was going on. And after that, there was no more splashing. And the fountain held up great. And we ended up placing third out of 18 different teams. We had some design challenges. Originally, we were going to build it out of concrete, but the fountain would have been very heavy and over 150 pounds once we calculated it all out. So we had to come up with a new material. We ended up doing some sort of combination of bamboo and wood. We had some issues with the water seals coming loose, and there was some leaking coming out that we fixed. And we had to increase the hole size at the top so that the water would go through and make the water wheel spin. At first, the lights weren't working, and we had to reprogram them with another light control application. And then we had an issue with the water wheel sticking to the rest of the fountain, and it wasn't spinning. So we had to rethink the way we were going to attach it to the fountain. So when we were brainstorming, we had different material ideas. We had bricks, which we discovered would be really hard to cut and were just too large. Concrete, as I've already said, was too heavy. Wood was very uniform, and then bamboo was very unique, lightweight, and had an earthy appearance. The shape, we decided that the basin at the bottom would be used to collect water. There was a vertical area for the water to flow up and then down, and we needed a space to incorporate the water wheel component of the fountain.
So for the modeling of the fountain, we used SolidWorks to create a 3D model. We initially made the base and the top portion of the fountain separately to the size we wanted, and then we made a final assembly where we combined the two of them. In the design, we included provisions for the water pump, the necessary tubing for the pump, and the water wheel in the middle. And we ended up retaining most of the original design in our construction of the fountain. So in the construction phase, we made the side panels out of bamboo, which was secured with hot glue and sealed up with silicone. The water wheel we made out of bamboo, which we cut down to size and sanded to fit together, and then we joined those together with hot glue. The base was constructed by cutting wood and plastic to our desired dimensions and then securing them together with screws. And a clear top panel was cut to the size we needed and secured between the two bamboo side pieces to create the top portion of the fountain. And we also added an LED light strip along the base of the fountain. The base and the top of the fountain we combined along with the water wheel to create our prototype. The water pump was installed and all the necessary tubing was added, and we drilled a hole in the top panel for water to drain out of and actuate the movement of the water wheel. And then we added a couple additional holes along the sides to regulate the flow of water.
The last step in our design cycle was testing. We had to test the flow rate of the water pump to ensure that it would power the water wheel correctly. We also had to test the water retention on the base and top of the fountain to ensure there was no leaking. The flow of water on the water wheel was tested to make sure that it was continuous and was functioning correctly. We also tested the Bluetooth LED lights to ensure that they could be programmed in the way we wanted. What would we redo? If we redid the fountain, we would use larger, more uniform pieces of bamboo, as in the construction it became difficult due to the bend of some of the smaller bamboo and due to the fact that we had to cut and glue many different pieces together. We would also use better wood for the base, so it was easier to cut and was more attractive looking. Advice for future freshmen: start early. Earlier in this year is a good time to start as you have less class material going on. It tends to be a time where you're not worried about exams. So start early, gather your materials early, and begin construction as soon as possible, as you don't know what types of problems may arise. Also, when brainstorming, consider producibility, as some designs can be too complex and may just add too much hassle to the process. Also, make sure the materials that you're using are good to work with and that they're able to be transported, as you will have to make it to the McKimmon Center.
One portion of our FEDD project required us to make an equation which would tell the volume of our fountain if it was filled up to maximum capacity. So for our fountain, we had two different equations we would use to find the volume. The first is the volume of a rectangular prism, which we use to find the volume of the base and the volume of the portion at the top of the fountain. The formula for this is the length times the width times the height. In this case, the base was 16.5 inches by 14.25 inches by 4 inches, making the total volume of the base 940.5 inches cubed. The total volume of the top basin was 9 inches by 3 inches by 1 inch, making it 27 inches cubed. The volume of the tube would be the volume of a cylinder, which is pi radius squared times height. In this case, the equation would be pi times half an inch squared times 16 inches, making the total volume of the tube 12.6 inches cubed. To find the total volume of the fountain, we added all of these values together, resulting in a total volume of 980.1 inches cubed.
This has been our FED presentation. Thank you for listening.
And watching.